ask someone where the internet lives, most people don't have an answer. Some will point to the cloud. Others will imagine satellites orbiting the Earth. Many simply assume it exists everywhere and nowhere at the same time. But the internet has a location, not one location, thousands of them, beneath our streets, inside highly secured buildings, across mountains, under the ocean floor, and between every major city on Earth. The internet is not floating above civilization. It is built into civilization. Its cables follow highways, railways, pipelines, power corridors, and international borders. Its buildings stand quietly inside industrial parks, business districts, and remote campuses, invisible to almost everyone. The digital world appears virtual, but its foundation is entirely physical. Understanding where the internet lives is a first step toward understanding how modern civilization actually works. Walk through any modern city. Cars move above, people cross the streets, businesses open every morning. But beneath the pavement, another city exists. A city built for information. Underground conduits protect thousands of fiber optic cables. These cables connect homes, offices, hospitals, schools, government buildings, and mobile communication towers. Most people never notice them because they were designed to disappear, just like water pipes, electrical cables, and sewer systems. Fiber infrastructure became another essential utility, quietly supporting daily life. Every online meeting, every digital payment, every navigation request begins its journey beneath the streets, long before reaching the global internet. Some of the world's most important internet infrastructure does not look extraordinary. From the outside, many buildings appear ordinary. Concrete walls, minimal windows, few signs, little public attention. But inside, entire digital ecosystems operate continuously. Routers exchange global traffic, servers deliver websites, cloud platforms process information, financial systems remain connected. Artificial intelligence responds to millions of requests. These buildings rarely become tourist attractions. They do not appear on postcards. Yet they have become as essential as airports, power stations, and financial centers. Because without these facilities, the internet would have nowhere to live. The internet rarely builds its own path. Instead, it follows the routes civilization already created. Highways become communication corridors. Railways become fiber corridors. Power transmission routes become digital routes. Because building new infrastructure is expensive, sharing existing corridors makes expansion faster, safer, and more reliable. This is why the physical internet often mirrors the physical world. Major cities become major network hubs. Ports become international gateways. Financial centers become digital centers. Economic geography gradually becomes digital geography. The architecture of the internet is deeply connected to the architecture of civilization. Not every city occupies the same position on the internet. Some simply consume data. Others move it. The world's largest cities have become digital crossroads, places where countless networks converge, where cloud providers build infrastructure, where internet exchange points expand capacity, and where global businesses establish their regional operations. Cities such as London, Singapore, Frankfurt, Tokyo, Ashburn, and Amsterdam have become critical nodes within the global internet. Their importance is not measured only by population, but by connectivity. Every additional fiber route increases resilience. Every new data center expands capacity. Every network connection strengthens the ecosystem. Over time, infrastructure attracts investment. Investment attracts innovation. Innovation attracts more infrastructure. The cycle continues until a city becomes indispensable to the digital economy. The internet may appear borderless, but its architecture is built around physical locations, and cities remain its most important anchors.
Cities alone cannot build a global internet. Continents must also communicate. That communication happens beneath the oceans, thousands of kilometers from land, far below the waves. Submarine fiber optic cables connect the world's largest economies. Every international video call, every overseas financial transaction, every cloud synchronization, every artificial intelligence request crossing continents travels through these hidden pathways. The cables rarely appear in daily conversation, yet they have become some of the most valuable infrastructure on Earth. Without them, global commerce would slow, cloud computing would fragment, digital collaboration would become far more difficult. The internet reaches across oceans, not through magic, but through engineering.
While cities sleep, the internet continues. Data centers remain active. Routers continue forwarding traffic. Fiber networks continue transmitting light. Engineers monitor global systems. Software automatically redirects traffic around failures. Cloud platforms distribute workloads. Financial systems process transactions. Artificial intelligence serves millions of requests. 24 hours a day, 7 days a week. The internet has no opening hours, no closing time, no weekends, no holidays. Modern civilization has become dependent upon continuous connectivity. The expectation is simple. Everything should always work. Behind that expectation is one of the most reliable infrastructure systems ever engineered, a system designed to operate without being noticed.
The internet moves at extraordinary speed, but it does not ignore physics. Distance still matters. The farther information travels, the longer the journey becomes. Even traveling at nearly the speed of light, data cannot arrive instantly. This is why companies build infrastructure closer to users, why cloud providers establish regional facilities, why content is replicated across multiple locations, and why businesses invest heavily in network optimization. Reducing distance improves performance. Improving performance enhances experience. The internet feels instantaneous because enormous investments have been made to overcome geography. The digital world still obeys the physical world, and geography remains one of its invisible architects. The internet does not simply connect computers. It connects civilization. Banks exchange trillions of dollars. Hospitals access medical records. Factories coordinate production. Aircraft receive navigation updates. Cargo ships synchronize logistics. Universities share research. Governments communicate securely. Businesses operate across continents. Every one of these activities depends on the same infrastructure, the physical internet. What began as a communication network has become the operating system of modern civilization. Entire industries now rely on continuous connectivity: manufacturing, healthcare, finance, transportation, energy, education, retail, artificial intelligence, cloud computing. The internet is no longer another technology. It has become critical infrastructure, just as essential as electricity, clean water, roads, railways, airports, and power grids. When infrastructure becomes invisible, people often forget it exists until it stops. Only then do we realize how deeply our lives depend upon systems we rarely see. The internet is one of those systems, quietly supporting billions of people, every hour, every day, across the entire planet.
The internet is often described as a virtual world, but nothing about its foundation is virtual. It occupies land, consumes electricity, requires engineers, depends on buildings, crosses oceans, and connects continents through physical infrastructure. Every digital experience begins long before information appears on your screen. It begins inside cables, routers, data centers, internet exchange points, and one of the largest engineering systems humanity has ever built. The internet did not replace the physical world. It expanded it, creating a second layer of civilization, one built from infrastructure instead of highways, from fiber instead of asphalt, from information instead of cargo. Understanding where the internet lives changes the way we see technology, business, economics, and power. Because every digital innovation is built upon a physical foundation, and every foundation tells a story. In the next episode, we go deeper into the technology that carries nearly all of the world's information, a strand of glass thinner than a human hair, capable of connecting continents and transforming the global economy. This is the story of fiber optics, the technology that made the modern internet possible. NEXNET, the architecture of modern civilization.